How are you? I hope all of you are well. I am Rizwana Mukhtar, lecturer, Department of Physics, Milestone College. In our previous class, you have already learned about the formulas and mathematical examples of chapter 10, which is ideal gas and kinetics of gases. In our today's lecture, I will go to solve two creative questions of this chapter. I hope this lecture will help you for your better study at home. Today's first creative question is from All Board 2018, and the question is: the volume of an air bubble becomes double when it comes to the surface of lake at the location A. In the lake, the pressure of air is 10 to the power 5 Newton per meter square and the temperature of the air is 18.6 degrees Celsius and the relative humidity is 54%. On the other day, in a lake of another location B, the temperature of air is equal to the temperature of location A and the dew point is 7.4 degrees Celsius. At temperature 7 degree, 8, 18 degree and 19 degrees Celsius, the saturated vapor pressure are 7.5 into 10 inverse 3, 8.2 into 10 inverse 3, 15.6 into 10 inverse 3 and 16.5 into 10 inverse 3 respectively. Now question number A is: what is standard pressure? You all know that every time air exerted a pressure on us. But what is standard pressure? Standard pressure is considered as at 45 degree latitude and 273 Kelvin temperature, the pressure exerted by mercury column of 76 centimeter height is known as the standard pressure. And the value of standard pressure is 1.013 into 10 to the power 5 Newton per meter square. You know that we can measure pressure from the formula P is equal to H rho D. So, in standard pressure, height of mercury column is considered as 76 centimeter, or we can write it as 0.76 meter. And rho means density, and density of mercury, you know that 13596 kg per meter cube, and G means acceleration due to gravity, and the value of G is 9.8. And after calculating it, you will get the value of standard pressure is 1.013 into 10 to the power 5 Newton per meter square or Pascal. Now question number B, and the question is: clothes are dried out slower in rainy season than winter season. Explain. You all know that wet clothes dried out due to the process of evaporation, and evaporation mainly depends on the humidity of air. That means if the humidity of air is less, that is amount of water vapor is less in air, so we can say that the air is dry or humidity is less, and at that condition the wet cloth will dry out faster. But if the humidity of air is greater, that means the amount of water molecule in air is greater, then the evaporation process will be slower. So we can say that as in rainy season the humidity of air is higher, so the evaporation process is less. That's why the clothes dried out at slower in rainy season compared to the winter season. Question C, and the question is: find the depth of the lake at the location A. Given informations are: the volume of air bubble becomes double when it comes to the surface of a lake. So, suppose it's a lake and the volume of an air bubble at the bottom of the lake is V1 and the pressure that is exerted on that air bubble is P1. According to the question, when this air bubble come on the surface of the lake, then the volume of that bubble become double. That means we can consider it as the volume of the air bubble at the surface of the lake, that is V2, and the pressure that exerted on that bubble is P2. Now you can see that when the air bubble at the surface of the lake, then only one pressure is exerted on that bubble, and that is the air pressure. But when the bubble is at the bottom of the lake, in that condition there's two pressure was exerted on that bubble. One is air pressure and another one is the pressure due to liquid. So we can say that at the lower surface or at the bottom of the lake, the pressure that is exerted on that bubble is P2 plus H rho G. P2 means the pressure that is exerted by the air and H rho G, that is pressure due to liquid. So with the help of this information, we can easily identify the depth of the lake. So let's start to calculate. So now we can see that the information that are given here is volume at the bottom of the lake, that is V1 is equal to V meter cube. Now pressure at the bottom, you can see that pressure at the bottom P1 is equal to P2 plus H rho G. Now volume at the surface, we consider it as V2, and V2 is equal to 2V. As here they say that the volume of an air bubble becomes double, so V2 will be 2V, and the pressure at the surface P2 is equal to, you know that at the surface the value of the pressure is 1.013 into 10 to the power 5 Pascal, and we have to calculate the depth, which is denoted by H is equal to what? So we can easily calculate this math with the help of Boyle's law, and you know that according to Boyle's law, P1 V1 is equal to P2 V2. Now I am going to put all the informations that's given here. Here P1 is P2 plus H rho G. V1 is considered as V, and the value of V2 is 2V. Now V and V is cancelled from both sides, so we can write that H rho G is equal to 2P2 minus P2, or P2 is equal to P2 by rho G, and P2, the value of P2 is 1.013 into 10 to the power 5. Now rho. Rho means density of water, and you know that density of water is 1000. And G, acceleration due to gravity. The value of acceleration due to gravity is 9.8. Calculating it, you will get the value of 8 is 10.33 meter, and this is the answer of question number C. Question D, and the question is, at what place as mentioned in the stem will a man feel more comfortable? To explain it, we need to know the relative humidity of both locations. As they gave the relative humidity of location A, which is 54%, so we have to calculate the relative humidity of location B. Then we can compare it that where the person will feel more comfort. So now the given informations for question D is air temperature. Here you can see that they mention that the air temperature is equal to the location A, and the air temperature of location A is given 18.6 degrees Celsius. So we can write that air temperature is equal to 18.6 degrees Celsius. Now dew point. Dew point is 7.4 degrees Celsius. And we have to calculate the relative humidity of location B. So we can write it RB is equal to what? Now you know that to measure relative humidity, we need to know the saturated vapor pressure at air temperature and saturated vapor pressure at dew point. Here you can see the given informations are the saturated vapor pressure at 7, 8, 18 and 19 degrees Celsius are given. But you can see that the air temperature is 18.6 degrees Celsius. So firstly we need to know the saturated vapor pressure at 18.6 degrees Celsius. That will be the value of capital F. So we can say that now saturated vapor pressure at air temperature is equal to vapor pressure or saturated vapor pressure at 18 degrees Celsius plus saturated vapor pressure at 0.6 degrees Celsius. So now capital F is equal to saturated vapor pressure at 18 degrees Celsius. They give the information is 15.6 into 10 inverse 3 plus saturated vapor pressure at 0.6 degrees Celsius. We can calculate it by change of pressure by change of temperature into 0.6. Now we can put the informations here. Change of pressure. Here we consider the change of pressure of 19 degrees Celsius minus 18 degrees Celsius. So that will be 16.5 minus 15.6 into 10 to the power minus 3 divided by, here the change of temperature is 1 and multiply 0.6. Now after calculating it, you will get the value 0.54 into 10 to the power minus 3. So at last we get the value of capital F, which is 16.14 into 10 inverse 3 meter of Hg. In the same way, we are going to calculate the value of small f. Okay. Now saturated vapor pressure at dew point or the value of small f is equal to, here you can see that the value of dew point is 7.4 degrees Celsius. So saturated vapor pressure at 7 degrees Celsius plus at 0.4 degrees Celsius. Now in the same way we are going to calculate it. So saturated vapor pressure at 7 degrees Celsius is given here 7.5 into 10 inverse 3 plus at 0.4, that means the change in the pressure is 8.2 minus 7.5 into 10 inverse 3 divided by change in temperature is 1, as 8 we are changing the temperature from 8 to 7. So change in temperature is 1 and into 0.4, 0.78 into 10 inverse 3 meter of mercury pressure. Now we have the value of capital F and small f. So we can easily identify the relative humidity. We know that the formula to calculate relative humidity RB is equal to small f by capital F into 100%. So we have the value of small f is 7.78 into 10 inverse 3 divided by capital F 16.14 into 10 inverse 3 multiply 100%. So after calculating it, you will get the value of relative humidity of location B is 48.2%. As here you can see that the relative humidity of location B is less than the relative humidity of location A. RB is less than RA. So we can say that a man will feel more comfortable at location B as our second creative question. And this question is from Kumilla Board 2017. Here you can see that they give a graph of pressure versus volume, and there's two gas. The temperature of X gas is 305 Kelvin and pressure 15 kilopascal. On the other hand, the temperature of gas Y is 405 Kelvin and pressure 21 kilopascal. And the stem, they say that 10 mole of two different type of gas X and Y is preserved in two different containers having a mass of 325 gram and 288 gram. The above figure shows the relation between pressure to volume. Now, question number A is define relative humidity. Humidity is the ratio of mass of water vapor present in particular volume of air at particular temperature to water vapor required to make the air saturated at that temperature, and relative humidity is denoted by capital R. So we can write that R is equal to small f by f into 100%. With this formula we can calculate relative humidity. Here small f means the saturated vapor pressure at dew point and capital F means the saturated vapor pressure at air temperature. Now question number B. The question is the dew point in Kustia is 15 degrees Celsius. Explain. Know that dew point means the temperature at which the air of particular area will be saturated with the water vapor which is present in it. So, the dew point of Kustia is 15 degrees Celsius. We can say that at 15 degrees Celsius, air of Kustia will be saturated with the water vapor present in it, or the dew will start to form at 15 degrees Celsius in Kustia. Question C, and the question is compare the volume of two gases. So here from the given stem we can see that the given informations are, in case of X, the temperature T1 is given 305 Kelvin. Pressure P1 is given here 15 kilopascal. 15 kilopascal, or we can write it 15 into 10 to the power 3 Pascal. Now volume V1, and in case of Y, temperature T2 is given 405 Kelvin. Pressure P2 is given here 21 kilopascal, or 21 into 10 to the power 3 Pascal, and volume V2. Now we have to compare the volume. So we know that P1 V1 by T1 is equal to P2 V2 by T2. Now we can write that V1 by V2 is equal to P2 into T1 by T2 into P1. Now I am going to put the informations which are given here. The value of P2 is given here, 21 into 10 to the power 3 into T1 is 305 divided by T2 405 into P1. P1 is given 15 into 10 to the power 3. So, is to V2 is equal to 4:7 ratio 4:05, and this is the answer of question C. Question D. Question is, which container will be empty early if kept open? Explain mathematically. You know that if we kept open of a gas container, then due to the diffusion, the gas will spread in the environment. So, we can easily calculate the which container will be empty earlier if we know the value of diffusion of two containers. So, here the given informations are mass of X gas M1 is equal to 325 gram. Mass of Y gas, that is M2, is equal to 288 gram. Now from question C we get the value of V1 by V2 is equal to 27 by 405. Now we know that diffusion, which is denoted by R, R1 by R2 is equal to root over rho 2 by rho 1. Now we can write that rho 2, that means M2 by V2. You know that density means mass by volume. So instead of rho 2 we can write M2 by V2, and rho 1 means M1 by V1. That is M2 by V2 into V1 by M1. So we can write that M2 by M1 into V1 by V2. Now I am going to put the all informations given here. M2 by M1, 8 divided by M1, 325 into V1 by V2, that is 427 by 405. After calculating it, you will get the value 0.967. So here by R2 is equal to 0.967, or R1 is equal to 0.967 R2. So we can say that R1 is less than R2. Here another relation between the diffusion and time is diffusion is inversely proportional to time. So we can say that T2 is less than T1. That means the Y gas will take less time to diffuse. So we can say that if we keep the both container open, then the gas of Y container or the gas Y will empty first. That's all for today. Thank you for being with me. Stay home, stay safe.